In the next example, let's try to turn this into a power series representation. Okay, so for example, I actually know that this is the antiderivative of 1 over 1 minus x. Okay, in fact, minus of this, because if you do the antiderivative of this, you get chained by the derivative of minus x. Okay, so that's gonna equal to this. Okay, so let me factor the negative out to the front. We just have a nice clean 1 over 1 minus x, and 1 over 1 minus x is can be easily represented as a power series. It's right 1 plus x squared plus so on, right? Okay, so let's find the antiderivative of that. You get x plus half x squared plus a third x cubed, and so on, right? With some constant at the end, right? Some constant at the end. So this part here can be just written with sigma n is equal to 0 to infinity, and it's just 1 over n plus 1 power of n plus 1. Okay, we still need to find the value of c, the constant at the end. So remember that this is equal to this, which is, we're almost done. We just need to find c, but recall that ln of 1 is equal to 0. So how can we turn that into ln of 1 when x is equal to 0, right? And x is equal to 0, we get on the left side is 0. On the right side, all that will turn into 0 because it's got a bunch of x's in it. So c is equal to 0. Okay, so which means, right, ln of 1 minus x is the negative of n starting from 0 to infinity 1 over n plus 1 x to the power of n plus 1. Now do you see that if I actually just change this counter, starting counting from 1, we can simplify this, 1 over n x to the power of n. Okay, that's nicer.